National Electrical Code Handbook, both in print and CD versions, are valuable resources for studying for electrical examinations and making informed decisions in the field. The commentary provided is generally helpful, although a complete reading hasn't been done. Suggestions for improvement are directed towards making the CD version a standalone product, eliminating the need to switch between the CD and the physical book. This is particularly relevant for users with smaller monitors, as the screen space can be inefficiently utilized. There are also ideas for enhancing the handbook's content. Firstly, the commentary should be more detailed. For instance, Article 250, which covers grounding and bonding, could benefit from expanded explanations. Secondly, including more examples would be beneficial. For example, Article 310, which deals with conductor ampacity, could include more practical calculations. The National Electrical Code Handbook serves as a valuable tool for electrical professionals and is frequently used for its helpful insights. Grounding and bonding are crucial for electrical safety. Grounding provides a path for fault current to return to the source, tripping a circuit breaker or fuse and preventing electrical shock. Bonding connects non-current carrying metal parts of an electrical system to create a low impedance path for fault current. This ensures that the voltage potential between these parts is minimized, further reducing the risk of electric shock. Article 250 of the National Electrical Code covers the requirements for grounding and bonding. It specifies the types of grounding and bonding conductors that are permitted, the methods for installing these conductors, and the requirements for grounding different types of equipment. Understanding Article 250 is essential for ensuring the safety of electrical systems. Conductor ampacity refers to the maximum current, in amps, that a conductor can carry continuously without exceeding its temperature rating. Article 310 of the National Electrical Code provides tables and guidelines for determining the ampacity of conductors. The ampacity of a conductor depends on several factors, including the size of the conductor, the type of insulation, the ambient temperature, and the number of conductors in a raceway or cable. Calculating conductor ampacity accurately is crucial for ensuring that conductors are not overloaded, which can lead to overheating, insulation damage, and even fire. Several factors influence the ampacity of conductors. Firstly, the size of the conductor, as larger conductors have a greater cross-sectional area, allowing them to carry more current without overheating. Secondly, the type of insulation is also a factor. Different types of insulation have different temperature ratings, which affect the amount of heat that the conductor can withstand. Thirdly, the ambient temperature, or the temperature of the surrounding environment, affects the rate at which the conductor dissipates heat. Higher ambient temperatures reduce the ampacity of the conductor. Finally, the number of conductors in a raceway or cable affects the ampacity of each conductor. When multiple conductors are bundled together, they generate more heat, which reduces the ampacity of each conductor. The National Electrical Code provides adjustment factors to account for these effects. In addition to grounding, bonding, and ampacity calculations, the National Electrical Code covers a wide range of other electrical safety topics. These include wiring methods, overcurrent protection, equipment grounding, and special occupancies. Electrical professionals should be familiar with all aspects of the National Electrical Code to ensure the safe and reliable installation and operation of electrical systems. Wiring methods refer to the techniques and materials used to install electrical conductors. The National Electrical Code specifies the types of wiring methods that are permitted for different applications. Common wiring methods include conduit, cable, and surface raceways. Conduit is a rigid or flexible metal or plastic tube that protects electrical conductors from physical damage. Cable is a factory assembly of two or more insulated conductors enclosed in a protective jacket. Surface raceways are metal or plastic channels that are mounted on the surface of a wall or ceiling to enclose electrical conductors. Overcurrent protection is the use of circuit breakers or fuses to protect electrical conductors and equipment from excessive current. Circuit breakers are devices that automatically interrupt the flow of current when an overload or short circuit occurs. Fuses are devices that contain a fusible link that melts and interrupts the flow of current when an overload or short circuit occurs. The National Electrical Code specifies the required overcurrent protection for different types of circuits and equipment. Equipment grounding is the connection of non-current carrying metal parts of electrical equipment to the grounding electrode system. This provides a low impedance path for fault current, which helps to prevent electrical shock. The National Electrical Code specifies the requirements for equipment grounding, including the size and type of grounding conductors. Special occupancies are locations that have unique electrical safety requirements, such as hospitals, hazardous locations, and swimming pools. The National Electrical Code has specific requirements for these occupancies to address the increased risk of electrical shock or fire. It is important to consult the National Electrical Code for the specific requirements for each type of special occupancy. Understanding the National Electrical Code is crucial for ensuring the safe and reliable installation and operation of electrical systems. Electrical professionals should be familiar with all aspects of the code and should always follow its requirements. The National Electrical Code is updated every 3 years, so it is important to stay current with the latest edition. In addition to the National Electrical Code, there are other resources available to help electrical professionals stay informed about electrical safety. These include industry publications, training courses, and online resources. By staying informed and following the requirements of the National Electrical Code, electrical professionals can help to prevent electrical accidents and ensure the safety of the public. The role of the National Fire Protection Association (NFPA) in developing and maintaining the National Electrical Code is significant. The NFPA is a non-profit organization that develops and publishes codes and standards for a wide range of fire and electrical safety topics. The National Electrical Code, also known as NFPA 70, is the most widely adopted electrical code in the United States. The NFPA develops the National Electrical Code through a consensus-based process that involves input from a wide range of stakeholders, including electrical contractors, engineers, manufacturers, and government officials. The NFPA also provides training and education programs on the National Electrical Code. The NFPA's mission is to reduce the worldwide burden of fire and other hazards and the quality of life by providing and advocating consensus codes and standards, research, training, and education. The National Electrical Code is an essential tool for electrical professionals, and the NFPA plays a vital role in ensuring that the code is up to date and reflects the latest advances in electrical safety. The importance of continuing education and professional development for electrical professionals cannot be overstated. The electrical industry is constantly evolving, with new technologies, materials, and methods being developed all the time. To stay current with these changes, electrical professionals need to engage in continuing education and professional development activities. Continuing education can take many forms, including attending seminars and workshops, taking online courses, and reading industry publications. Professional development activities can include obtaining certifications, participating in professional organizations, and mentoring other electrical professionals. By engaging in continuing education and professional development, electrical professionals can enhance their skills and knowledge, improve their job performance, and advance their careers. Moreover, continuing education helps ensure that electrical work is performed safely and in compliance with the latest codes and standards. Neglecting ongoing learning can lead to errors, safety hazards, and potential code violations. Therefore, a commitment to lifelong learning is essential for all electrical professionals. Let's delve deeper into specific articles within the National Electrical Code, like Article 314, which covers outlet, device, pull and junction boxes, conduit bodies, fittings, and handhole enclosures. These enclosures are crucial components of electrical systems, providing protection for conductors and connections. Article 314 specifies the requirements for the construction, installation, and use of these enclosures. This includes requirements for the size and type of enclosure, the number of conductors permitted in an enclosure, and the methods for securing and supporting enclosures. Proper selection and installation of these enclosures are essential for ensuring the safety and reliability of electrical systems. Similarly, Article 430 addresses motors, motor circuits, and controllers. Motors are used in a wide variety of applications, from powering appliances to driving industrial machinery. Article 430 provides detailed requirements for the protection of motors from overloads, short circuits, and other hazards. It also specifies the requirements for motor controllers, which are used to start, stop, and control the speed of motors. Understanding Article 430 is essential for anyone who works with electric motors. The NEC also addresses low-voltage systems, often used for control circuits, lighting, and other specialized applications. These systems operate at voltages below 50 volts and have specific requirements outlined in Article 725 for Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. These classifications define the power limitations and wiring methods permitted based on the potential energy and risk associated with the circuit. Proper installation and protection are crucial to prevent fire hazards and ensure safe operation. Another important aspect of the NEC is its focus on hazardous locations. Article 500 and subsequent articles address the requirements for electrical equipment and wiring in areas where flammable gases, vapors, dust, or fibers may be present. These locations are classified based on the type and likelihood of the hazard. Equipment used in these locations must be specifically designed and tested to prevent ignition of the hazardous materials. The NEC provides detailed guidance on the selection and installation of equipment in hazardous locations to minimize the risk of explosion and fire. Surge protection is also a critical consideration in modern electrical systems, protecting sensitive electronic equipment from voltage spikes caused by lightning, utility switching, or other transient events. Article 280 of the NEC covers surge protective devices. SPDs provide requirements for their installation and location. SPD are designed to divert surge current away from protected equipment, preventing damage and downtime. Selecting the appropriate SPD and installing it correctly are essential for ensuring effective surge protection. Renewable energy systems such as solar photovoltaic, PV, and wind power are becoming increasingly common. The NEC includes specific articles to address the unique requirements of these systems. Article 690 covers solar PV systems, addressing issues such as disconnecting means, overcurrent protection, grounding, and wiring methods. Article 694 covers small wind electric systems, with similar requirements tailored to wind energy. These articles ensure the safe and reliable integration of renewable energy sources into the electrical grid. The National Electrical Code is a comprehensive document that covers a wide range of electrical safety topics. Electrical professionals should be familiar with all aspects of the code and should always follow its requirements. The code is updated every 3 years, so it is important to stay current with the latest edition. In addition to the code itself, there are many other resources available to help electrical professionals stay informed about electrical safety. These include industry publications, training courses, and online resources. By staying informed and following the requirements of the National Electrical Code, electrical professionals can help to prevent electrical accidents and ensure the safety of the public.